So now we're on page 98, and we're going to try using our two formulas and compare what happens. So our new formula, compounded annually, with the t being up as an exponent, is right here. And our simple interest formula, where t is on the same level as everybody else, and it's inside the parentheses, we've got our formula right there. This is the table from page 98. We're going to work on filling that out. So we want to know how much this is same account we just did. $600 principal, 5% interest rate. We want to know how much we make using these two formulas. Okay, so in both formulas, the P, the R, and the T mean the same thing. They're just in different places. So for the compounded annually, I can get this right. Our principal is $600. Same thing for simple interest. My interest rate is 5%. My interest rate is 5%. Now, to fill in this table, the first one I want to know is after 10 years. So I'm plugging in 10 for T. So 600 times 1 plus 0.05 raised to, ooh, that didn't write real well, raised to the 10 exponent. Now, this is where we need to exercise those good order of operations. We need to multiply everything that's in, or add everything that's in this parenthesis. We need to take care of inside the parenthesis and then raise it to the 10th power before we multiply by the 600. So what I will do on my calculator is type in 1 plus 0.05, enter. And then I take that caret to the 10th power, enter. And then I multiply it by 600. And I'm going to round it to the hundredths place for cents. With simple interest, plug in all these things in. And once again, I'm going to take care of my order of operations. So I'm going to multiply this 0.05 times the 10 first. And then I'm going to add 1. And then I'm going to multiply by 600. So when I do this by hand, it's going to look almost exactly the same, except instead of the 10 for the 10 years, I'm plugging in 20 for T. All the other numbers are the same. Plugging in 20 for T instead. Still the same principal, P. Still the same rate, R. Of course, once we have that different number 20 in there, we're going to get a different answer. Let's see, got it written down here. If we do it in Excel, just watching all this happen again, I can take what I did on the previous line, and I'm going to copy it and paste it. And then all I have to do is go in and change, instead of plugging in 10 for T, I'm now plugging in 20. Simple interest, I'm using that same simple interest formula, except instead of the 10, I'm plugging in 20. for 30. I don't know where that 900 came from. Here we go. For 30 years. Instead of 20 and 50, I'm putting in 30. Same formula. Here I'm using the same formula. The only thing that's changing is the t. And then of course you do the same thing for 40. So if we try it by hand again to do 40 years, instead of, well, maybe, there we go. Now I'm plugging in 40 for t. Otherwise, everything's the same. 600 times 1 plus 0.05 to the 40 exponent. And then similarly for simple interest. So I've remade this chart, but instead of saying after 10 years, after 20 years, I just put the number of years. It'll make my graph work out better. So to use Excel to make a graph, I am going to select my chart and go over to Insert, and I'm going to pick Scatter. Now, when you are making a graph, it's really important to label everything. So, this is just, let's have to go. This is just, we'll call it future value. So it's just telling after so many years, how much is this account worth? But we need to label what the vertical axis and the horizontal axis are. So I'm going to go to Add Chart Element, and this is number of years, which you have in your book. And over here we have our future value. Now, Excel kind of figured out how tall to make it, how long to make it. When you are making your own graph, they've given you a grid, but they haven't told you what to count by. Do you count by 2s? Do you count by, here Excel is counting by 5s, but you're probably not going to want to count by 5s on yours. If you look at your chart and you say, let's scooch this guy out of the way. You look at your chart and you say, well, how far do I need to be able to go? Well, I need to get to 40. So you look at how many tick marks you have going along the bottom, and you say, what should I count by to have them nice and spaced out, but still be able to fit 40? Then when you're figuring out what to count by vertically, we also want to think, how high do I need to go? Well, my highest number is this one. So maybe I'd want to make 4,500 my ceiling. Maybe I'd want to make 5,000 my ceiling. I want to use up all my space, but I also want to get it all to fit in. It looks like it fits really nicely if you count by 200s going vertically. So finally, when we look at the two different types of interest, you can see how after 10 years, they're still pretty close. By the time we get to 40 years, there's a huge difference. And I'll throw some important words at you that you won't need quite yet, but let's just get them started, taking root. The simple interest, which is growing by a constant value, that $30 every year, is linear growth. Whereas the exponential growth that we see with these blue dots is what we have with compounded interest.